Bismillahirrahmanirrahim. Now, this is the first of a set of videos that I've made for your revision purposes. In this, I won't be covering all the slides. I will be covering the main concepts. Obviously, you will have to study all slides for your exam, but I will be covering the concepts which I feel need explanation, inshallah, so you can revise them. Now, I'm beginning with slide number 4, and here we're looking at the network layer services. What are the services that the network layer offers? The first service is packetizing. Packetizing means to convert the data that has come from the layer above into a packet, into a network layer packet. Okay, so which means we have in here, we have the TCP segment sitting at the top, and then it comes down, and then we add the IP header, right? We add the IP header to it. So this portion is, as you know, called the payload, and this is the header. So this is encapsulation. Then it goes to the other side, and then we have a decapsulation process taking place. Okay, and this is decapsulation. So the payload, you take off the header and you move it up. So this process of attaching the address, or the IP header which contains the address, is called packetizing. So you're encapsulating the payload in a network layer packet at the source and decapsulating it at the other side. And what is a significant feature? You are carrying the payload without changing it or using it. This is very important. Okay? You're not changing it and you're not using it in any way. Just like a post office. In the post office, when you want to send something, or a letter, for example, you place the letter in the envelope, you write your address on it, and then you post it, or you go and give it to the post office. The post office does not open your letters and read it, nor does it use anything from that. It simply takes the letter, looks at the destination address, and forwards the letter to the right destination. The next service we're looking at is routing and forwarding. So in this case, we've seen this in class. On the internet, we have many routers sitting between the source and the destination, right? So we have many routers. Now, routing means that you are choosing the best route from the source to the destination. Okay, this is called routing, finding the best route. And then we have the next function they mentioned, which is forwarding. And forwarding means anytime a packet arrives at a router, it's going to check its forwarding table and see where that packet is supposed to go. And then, based on that, it will forward the packet to the next hop or the next router in the path. So this is called forwarding. So you create a connection between an input port and an output port and find the best route to the destination. This is the forwarding process. We have a router with 4 interfaces, and this router has got a forwarding table inside it. And the forwarding table lists the incoming address or the destination address of the incoming packet and where should it go. So for example, we're having a packet coming in with the destination address B. And then the router will look at B and it knows that anything with a destination address B should be forwarded to output interface 2. And that's what we're doing here. Okay, so we forward it in here. So this is the forwarding process. Next, we are looking at packet switching. In packet switching, we are not establishing a route before we send the packet. We just take it and send it over the network. And the routers will then decide based on the quality of each link where should they forward the packet. So and this is called the datagram approach, which is taking place at the network layer. So we have a sender and a receiver. Sender has sent the packets 1, 2, 3, and 4. But because there is no connection between the sender and the receiver, each packet will take a different route based on the characteristics of the network. So for example, 1 came in and 1 was sent to R1, R4, R5, and then out. Then we had packet 2, but packet 2 did not take the same route as R1. Packet 2 went R1, R2, R5. 3 goes R1, R3, R4, R5, and the receiver. And 4 goes R1, R3, R5, and to the receiver. So we are seeing that all packets take a different route, and they all, because of this, some of them might get delayed and they arrive out of order. So we're not seeing an order of 1, 2, 3, 4. We're seeing an order like we had here. Okay, we're seeing an order of 2, 4, 3, 1. And this, as I said, is happening because we are having the packets taking different routes in the network. It's showing in here again the forwarding table, which is similar to the concept we looked earlier. Now we are looking at the virtual circuit approach. In the virtual circuit approach, we first establish a connection between the sender and the receiver. This connection is virtual. And it's virtual because when we finish this transmission, we can remove that circuit and we can reutilize the bandwidth and the resources for another connection. So as you can see here, a virtual circuit has been established and sender will send packets 1, 2, 3, and 4. All the packets now are arriving in the same order at each router, unlike the previous datagram approach that we saw. And they're all arriving in the same order at the receiver. So you won't see packets going here and there. They all systematically follow one route only. In virtual circuits, we have the concept of labels. So each packet is attached a label. So for example, in here, again, we have the router, and the router is actually having a table inside it. And that table says that if packet with label L1 arrives on port 1, change the label to L2 and forward it to port 2. And this is what's happening. The label has been changed to L2 and it is now being forwarded on port number 2. Now, this figure shows us how we're going to establish the virtual circuit. I'm going to play this in the full screen mode. So in the process of making the virtual circuit, we first send a request packet. This request packet contains the source address and the destination address. And we said that the routers already contain the routing table. Okay, the routing table is already there in the routers. So they know when the request packet comes in, they know which router to forward it to. Okay, so in this case, A is first sending the packet, the request packet. So it arrives at R1. R1 looks at its routing table and knows that it will now send to R3. However, before doing that, R1 will now create entries in its table, a different table, okay, the labels, the table for the labels. So it says that there is a packet coming in on port 1. Okay, we have a packet coming in on port 1, and this packet, router 1 assigns it a label 14, and then looks at its routing table and knows that this packet should be forwarded to port number 3. And it does that, okay? It forwards it to port number 3. However, we don't know the label yet for the outgoing packet because this will be established by the receiving router. So for example, in the first router R1 is a receiving router for the packet that comes from A, and R1 assigned it a label 14. Similarly, the packet is now going to go to R3. R3 is the receiving router, and R3 will assign this packet coming in, the request packet, it will assign it a label 66, and it will know from its routing table that it needs to go to port number 3. And that's what's happening here. Okay, so now the packet has been forwarded to port number 3. However, again, we do not know what the outgoing label is. From R3, it goes to R4. R4 again looks at it and says, there is a packet coming from R3 okay, there's a packet coming in from R3, and when this packet comes in, R4 will assign it a label 22 and then forward it to port number 4. Now port number 4 actually contains the destination. But the packet with the label 22 has reached B. Then what B does is that, so now one route has been established from A to B. So now B needs to send a confirmation message saying that the circuit has been established. Now we know that this packet has got the label 22, right? The packet that arrived at B. Now B is going to send a response packet. Okay? B is going to send a response packet, a confirmation packet along the same route. R4 will look at the packet and assign it a number, a label 77. Remember, it's the incoming routers that assign the label. So in this case, R4 has assigned it label 77. And then R4 will take the packet, so it knows now that port 4, a packet with label 77 has arrived. It needs to be sent to port 1 with label 22. 22, we already know about it. So 22 now arrives at R3. And R3, because it's arriving on port 3, from R4, R3 will save that entry into its table. So in this way, on the way back, all the tables get filled with the entries of the route. Now based on the table again, R3 will remove 22 and put 66 in the label and send it off to R1. R1 knows that when a packet coming in on this, when a packet is coming in with this address, with label 66 on port number 3, we assign it a label 14 and send it to port 1. So that is done. So now the circuit is complete. Okay. Then A will actually start sending packets to B. So there you go. A is sending a packet and the label assigned to it is now 14 because A knows the number. It arrives at R1. R1 sees packet arriving on port 1 with label 14. Send it to port 3 with label 66. So it is now sent to R3 with label 66. And then when it arrives at R3, R3 knows that anything coming on port 1 with label 66 should be sent to port 3 with label 22, and that's what it's done now. Okay, it has sent the packet with label 22. Once again, it arrives at R4. R4 looks at it and knows that the destination exists on port 4. However, the packet has come from on port 1 from label with label 22. So it should now be sent to port 4 with the label 77. So this was about the different features of the network layer and the services that it offers. So I will stop the video in here. The next one we will continue with is network layer performance.